Okay, so this talk will be in English. We have foreign guest. This is Julita from Peru. Currently, she's doing her master's study at high performance computing at the University of Edinburgh. So, welcome, Julita.
Thank you, Pam. Well, I started in the Linux war in 2011 with Genome. Has anyone known Genome? No?
Yes.
Just
Everybody knows about it.
And then in 2012, I had the opportunity to meet Fedora people. I went to Republic Czech, and then I became ambassador in Peru. After those experiences, I was gaining experiences. I did some conferences around the world about basically workshops on how to use Linux for beginners, because sometimes it's difficult at the beginning how to switch from Windows to Linux. Then I was working in IBM as a Linux administrator. And so suddenly I realized that HPC operated computing is the future. Well, in Europe it's the present, but in my country or in Latin America it's not so common. So that's why I came to Europe to do a master in HPC. Okay, everyone have heard or knows about love of Moore, right? Which he says that the computers or number of transistors will be doubled every 2 years. When was this proposed? It was proposed in 1965, and after more than 40 years, we still know that this was true. The number of transistors was doubled every 2 years. It was like reference for manufacturers or CPU companies, manufacturers of CPUs companies take into consideration this. Also, if you have more transistors, it's not just to increase for doing more things in a processor. It involves power, it involves speed. What else do you think it involves? Yeah, very good. It was about power. This study showed that recently, well, it was not recently, it's more than 10 years, but still it was, they confirmed that the performance was rising as the number of transistors were rising. But what about the programmers? We were taking just into consideration the hardware, but the programmers did something for those years, because we were talking about 1965, and now after more than 40 years was recently convention to release OpenMP or POSIX or any parallel programming. What the programmers did at that time? What do you think?
They did their own thing.
The wrong thing. So we were talking that the power wasn't exponentially rising, but it was nearly to be near to be a quadratic equation. So if we are talking about the number of transistors grow up, the speed also increase, the performance, and the computers were like increasing just in one chip, increasing just in circuits, the charge, but having in consideration the electrical charge here and the work it did, we can resolve or infer into the power. But the power and the heating increases in a serial computer, in an architecture that it has only like this serial diagram. Like you have an input, you do the calculations, and then you have an output. Suddenly, they say, okay, let's split the frequency and double the capacity on each processor, and then we'll calculate the same work with this new scheme. And they found that this core architecture was decreased in, or they save more than or around 40% of power. So this new proposal was taken for some CPUs manufacturers. Like they started to not just work with one core, they were starting with 2, 4 in parallel. Companies like AMD or ARM, Intel, IBM, as well as the power, performance, the speed, the transistor, number of transistors increase. Also the data. We are now, when we were starting since this year, the operation per second started to grow up until nowadays we are towards the exaflops. And well, in this case, we can say after all these theories that it's not just about hardware, it's also about software. When we are talking about software parallelism, we can mention ANDL. How many of you are familiar with the ANDL law? Everyone. Okay, well, I have, indeed. And what is this theory does mention it? Like even if you have a serial part of your code, you can reduce the, you can make the efficiency by increasing the number of threads. But even if you are reducing your time, or in this case the speed up was you have more faster code, you still have an overhead, right? You don't have an entire program like it's going to be that you have threads to be applied into the code in parallel all the time. You started with one thread with the declarations, the initial values, and then you started with the parallelism, and then you reduce those or gather those results, and then you finish with one thread at the end. You get it? So this is this part of the beginning of at the end, or in the middle. It can be also. That is the overhead in our program. So we still have that, and there is a top when you do the parallelism. Even if you increase more 16 or 32, you are going to have the same overhead. It was all clear with the people who didn't raise the hand? No? Yeah. Just tell me. We are here to learn. And then, well, this is in mathematical description of the ANDL flow. So you have when you have the parallel, in this case, this is the serial part, and when you increase the number of threads, as I told you, if you have a longer, you have always zeros here, like that's always the overhead. That's traditionally what I say in math. But later, after 10 years later, Gustav Thom says like, okay, it's true that even if we have more threads, we have that we still have the overhead, and it cannot be like efficient. But in this case, he said, your formula can be applied for a large amount of code. I mean, Gustav Thom confirmed that it was good, but it was better to apply in larger programs. Inca? When we are talking about parallelism, we have in consideration first the concurrence. When we don't see the programs like we are right now running this presentation, but in the behind or in backend, it's running the operating system and also running a program. So it's invisible for the final user, the concurrency, right? But when they started to apply the concept of parallel execution, they combine these concepts, and then it's possible to do it. The manufacturers of CPUs also have that. For example, if I'm going to show you later that some algorithms for the cores are applied in order to fill the space, but to make it the parallelism. When you are starting a cluster from scratch, like saying, you have to think in the architecture you are going to apply. You have to consider memory, how where it's going to be, how the cores are going to work with it, and one proposal is to use it in share. You can share the memory. And what do you think is the other proposal? Is that each processor can have their own memory. So this distributed memory computer has their own memory that work with his core, but in real, the machines, the clusters that I have known, they use this hybrid solution, like because you can combine OpenMP or any other programming parallel programs using in one node the shared memory, and then API or any other language using a distributed architecture. It was clear what I said already? And you are familiar with the top 5.org list, that nowadays we have 100% in Linux, which is the supercomputer, the first one in the world. What's the name?
Chiroque?
The Summit?
Summit,
No,
IBM.
it was China
Now it's United States.
until June of this year. I was lucky to be in the event in USA at RNL in the laboratory this year. I did also an internship there with supercomputers. And nowadays, the first one is in the world is in US. It's called Summit. And the operating system that Summit has is Mac? What? Linux, but what distro?
Yes.
The distro is
Ubuntu.
no, it's not Ubuntu. It's Red Hat 7. So we as a Linux administrators, we can have opportunities to work with them. I know that you can submit your jobs, your proposals online to RNL. There is a special department that evaluates the projects, and it doesn't matter the field, because I also saw a project related to dreaming, like what you dream, and you have to explode a lot of data and predict what you have in your dreams in a week. So we are projects, also like the cancer, genomics, the popular climate. But if you are interested in something, you just can do it online. there is a department I told you, it's free, and you can use the resource of Summit. So, when we are talking about architectures, we have to take into consideration these four, four items, like the principal technologies of processors. What do you think are the innovations in processors? We know that what a processor does, have an input, do calculations, have a result, you execute instructions. What else you do? You don't do. The processor, what the processor does is to load and store data, then use an algorithm to fetch what is going to be next, or what to decide what will be the next instruction. The critical characteristics, I think, when you are deciding to buy a CPU, a new computer, or you're designing an architecture of clusters, you have to take into consideration the clock speed. You know nowadays which one has more power, like IBM 9, the core. Well, that's what the Summit use. Nowadays, we were deciding about how to do a new proposal for a cluster, and we were evaluating especially the power of each processors. I mentioned in the AMD, ARM, but we are also in these days we have to take into consideration deep learning, other technologies. Usually GPUs is a hybrid proposal to be with CPUs to work and manage those kind of data. But I think it's critical to decide about the clock speed. As you mentioned, the heat can produce also noise. If you enter to Archer lab in Edinburgh or in Summit in USA, you have to be careful with the noise because it's very noisy. The peak load capability is also another point to take into considerations. And I was mentioned like for innovations, I can mention also that the use of FPGAs, but it's to implement it you need to configure it like code in the hardware, so it's quite difficult to do. The distinction of risk and risk is just, in the past we were like very clear differentiation of this, but nowadays you can work with both in a computer. The implementation of pipelines can make run faster a CPU. Well, the simultaneous multi-threading. Nowadays we have to take into consideration also like how many threads a processor has. Papers. This project of Epiphany, have you ever heard about it? Like this processor into parallel. This model is new. One of the things that a company has to be aware of is the budget you are investing in designing a new core, and the budget is until $1 billion. So you cannot pass that amount of money. And at the beginning it was a very expensive proposal, but nowadays you can get Adapteva. There's a company, in this case Adapteva core for $19. This initiative started in 2008. So if you find in the website, there is a lot of information about it, as well as a proposal of MIT, a Swarm project. which considers also multi-core CPU to make it to boost the capacity, the potential in the CPU. Okay, let's talk about memory. Before going to memory, you have any question or comments?
So you mentioned apparently different proposals, but what is the outcome? Is anything? Do people build clusters from non-Intel architectures?
Summit is power line.
Yeah.
It's
Okay, and anything from AMD? ARM, sorry, from ARM. Would it be possible to be?
Yeah. I think ARMS is very like ecologically solution. You can do your cluster, but what I am from what I understand of Summit, it doesn't have that. Edinburgh neither. But when I started in this work, I built a cluster with 8 nodes with just Raspberry Pis to see the communication, to study the communication. And if you want to do with ARM, I think the compatibility with GPUs is not optimal, but I think you can do it. So you just put the question. Any other? Okay. For memory, well, we have this notion that we have dynamical memory and static one. The number of transistors is a clear differentiation. Also, even if the capacity of dynamically runs of memory has grown in 60%, the speed didn't increase so much. Like you have 7% per year. The use of cache was included because, well, the levels of cache is level 1, level 2, level 3 were introduced also for memories. Static rounds are faster, are expensive, but what do you think you need to refresh every time? If I'm telling you, like dynamically, is the it is mainly used for the main memory, and the static for cache. What do you think you need to refresh? Which one?
dynamical.
Dynamical. Everyone says that?
Cache.
Cache. Static. This group. What do you think? Well, the answer I think is static because it was in that way. But what are the innovations in memory? The wide memory path, the interleaving. The interleaving is a concept that we have to work with the motherboard. Well, I mentioned about GPUs. This concept is new for Intel KML. Virtual memory, like nowadays, it has to work with multiple processors physically. The interconnection also, like we have to take care the voltages we apply to wires, the optical pulses. Well, we are talking about in this case more. Not only we are not having into consideration just the CPUs and the memory. We have to interact with the motherboard. In these cases, that's what I mentioned, the pulses, the waves, the propagation in the air. How many of you knows the concept of bisection? when you're talking about network. When we are talking about network, we have many topologies, right? Like the ring, the star. Nowadays, there is a concept like called cube. Cube, like you replicate one structure to other, like a mirror. But if something happens in the network, like it's called the bisection is like you to divide it into two, and you have to take care what is the impact, what is the path you are affecting if you cut it. What are the, how do you say, the neighbors? If you cut in a ring, for example, if you have this, if you have 32 cores, the bisection would be 16, right? But if you do the bisection, you just cut, you are impacted into two nodes, because it's just this, right? But if you have any other topology, it's different, the number. So in this case, what I saw is like the bisection is a new parameter to have to take into consideration, because one is the diagram, the other is the diameter, and the other is the nowadays is the bisection about the impact of the links you are preventing if you fell into the interconnection. Well, this is new for not new, but we use InfiniBand in HPC. How many of you have heard about InfiniBand? But what is the obtain, for example, obtain memory? Use another one. Which one is? It's like a competition of InfiniBand. Does anyone know? See,
Omnibus?
yeah, that's it. Thank you. Yeah. So when we were designing also the cluster, we had we are using right now a core of the IBM9 with the Obtain and the OmniBand. No, it's not usually, if you are talking about cluster, oh, you related the network with this, but there are other options, as I mentioned. And okay, what else can I say on this case? This was I was mentioned about the bisection, like the torus has like a backup. I would if you search about these topologies, they are not like just the ring or the star that we are familiar with. I think this is the most used nowadays. And the dragonfly. About storage. We are familiar with the HHSD and SSID, but if we are towards the scale trends in the I/O, we need to face also the traffic. The feature of traffic of I/O is important. So what I found is that they are using not only, you don't have to take into consideration just the amount of data you can store. You have to also take into consideration the file system. Nowadays, you have with Hadoop the file system of Hadoop.
HDFS.
Thank you. And but there are other options, because Hadoop is just like a commercial proposal. But if you are in the scientific field, you have to work with other solutions like MPI or a mix of OpenACC, other languages. They use another kind of file system like Lustre or
Gloucester?
Lutterface, yeah. And well, you have to. I told you like the capacity is just one feature that you have to see, but you have to also evaluate the file system or other things, because if we have talked about the supercomputers in the top 500, but do you think what they are measured by a link path, but it's not the same nowadays. It's just not only that. It's not what HPCR measured. We have many others like. It's not the same. The purpose. I want to say the purpose. I'm sorry. Like you asked me before, like what if I started to build a cluster with ARM instead of using IBM cores? You need to consider the purpose of your machine. Most recently studies were considering the multiplication of metrics, and that has a different algorithms. Right, and also there is another measure that it cannot be included in the link path for that. I don't know how to say this. There are according with the purpose of your project, you need to design the cluster, and then the functionality is not going to be the same if you are talking about, as I told you, like multiplication of matrices or just like Hadoop does, gathering, reducing, and then other operations. I don't know if the last idea I wanted to say was clear. No? Yes?
There is no general purpose parallel computing, in other words.
Yes. Thank you. That was what I wanted to say, but to do that, you have to take into consideration that the four technologies, like was listed, the CPU, the memory, the storage, and what was the other?
Network.
Yeah. So the references are there. The links are also on each slides. This presentation is also available in my GitHub, JINCA. Do you have any other question? Thank you.
So do you think that it will be, like in the next year, it will be a bigger supercomputer than the Summit?
Yeah, I cannot say, but I know what is the project of RNL for 2021, because China was in the 2 last years the leader. United States was in 2012 with Titan. But nowadays it's Summit. You know that Summit has electricity, the same electricity that San Francisco consumes. So the cooling system of Summit is if you go to the top, you see a swimming pool. So nowadays the solutions are taking cooling liquid technology for CPUs. But it is too noisy. To enter there, you have to have a special equipment. Because it's faster, it's related to the performance, the heating, and the noisy too. I told you that USA is working right now. That's where I'm trying to be more prepared to be included in the project. Yeah. Because it's recording, I cannot say the name of the project or what they are planning, but yeah, it's not just about to adding more CPUs or adding more memory, it's also about the design, the interleaves, the pipelines. China maybe it's also work. I really don't know anything about Chinese projects. I hope you like it, the presentation I tried to do it. Or you understand me English? No? Yeah? Thank you so much.
So I have a question about because we're having a workshop session. How should we prepare our machines?
Yeah. All of you has a Linux or Mac. What do you use? All of you?
conference.
I know, but because what is the version of GCC you're using?
8.1?
I think it's already included for 4.5 GCC.
Yeah, everyone has a little bit for sure.
Yeah. Because we are going to work basically. Have any of you worked with OpenMP? You're the most enthusiastic. I don't think that the others know, but he's always asking questions. But okay, we're going to do is a small for loop, and we are going to apply the static, dynamic, and guided directives to see how fast it is to parallelize it as serial program. That's it. That's the idea.
Okay.
But yes, you're right. If you have GCC 4.5, you are ready. But if not, I think we can give you an answer to zeros. I don't know what is the answer.
We'll figure out something.
Yeah.
It will be, of course, C++ or some different language.
So only C. Because I also know that for scientific purpose, in RNL they are working mainly in C and Fortran. That's it. But I know in Edinburgh they are working with, you can work with C++ too, I think, right? Okay, thank you again.
Yeah.